So I welcome to this session. So now we go to see the quadratic form to canonical form. Consider the general expression a11 x1 square. So a12 x12 x1 x2 plus up to etc. a1 n x1 xn. So plus to up to etc. a n xn square. The general expression is this. So which is a homogeneous polynomial of second degree and is known as quadratic form with the variables x1, x2 up to etc. xn. So it is denoted by q is equal to sum of I varies from 1 to n, sum of j varies from 1 to n, a I j, so xi xj. So the above expression can be written as q is equal to x transpose a into x, where a is equal to a11, a12 up to etc. an, so n cross n matrix, x1 is nothing but x1, x2 up to etc. xn, n variables. So the matrix A is called matrix of the quadratic form Q. So the matrix A of above quadratic form must be symmetric matrix, which makes it symmetric by the substitutions. Cij is equal to 1 by 2 Aij plus Aji, that is Aii is equal to Cii and Aij is equal to Aji. The rank of the n cross n symmetric matrix capital A is the rank of the quadratic form of Q. So if the rank is less than n, where n is the number of variables, then the quadratic form is a singular, otherwise it is non-singular. So the linear transformation of quadratic form, let q is equal to x transpose a into x be the quadratic form in the n variables x1, x2, x3 up to etc. xn. So consider the transformation x is equal to cy. The transformation, the variable set x is equal to x1, x2 up to xn whole transpose, the new variables, that is y is equal to y1, y2 up to etc. yn whole transpose. Here C is the non-singular matrix. So we can easily verify the transformation x is equal to cy, express each of the variable x1, x2 up to etc. homogeneous linear expression in the terms of y1, y2 up to etc. yn. Hence x is equal to cy is equal to non-singular linear transformation. By this transformation q is equal to x transpose a into x is a transformed to, so q is equal to, instead of x I can replace cy, we will get this. Therefore cy we can take as y transpose c transpose a into c y. So c transpose a into c is nothing but d is diagonalizable. So d transpose is equal to c transpose a into c the whole transpose. C transpose a transpose c is equal to simply d. So this is shown that D is also a symmetric matrix. Hence D is a matrix of quadratic form y transpose D into y in that variables y1, y2 up to etc. yn. Thus y transpose D into y is a linear transformation of the quadratic form. So x transpose A into x under the linear transformation x is equal to cy, where D is equal to c transpose A into c. So orthogonal transformation of quadratic form to canonical form. Consider the linear transformation x is equal to c into y, where c is chosen such that d is equal to c transpose a into c, a diagonal matrix, then the quadratic form q is reduced to like this. So therefore q is nothing but y transpose d into y. So y is nothing but y1, y2 up to etc. yn. So y transpose is this, so multiple. So D is a diagonalized matrix. Diagonal entries already we know that one, only diagonal entries are there. The diagonal entries are eigenvalues. So y is nothing but, so a column matrix y1, y2 up to etc. yn. So we can multiple these three matrix, we will get, so lambda 1 y1 square, lambda 2 y2 square up to etc. lambda n yn square. The above expression of q is called sum of the squares of q or canonical form of q. If C is the orthogonal matrix in the transformation x is equal to cy, and if x is equal to cy transforms the quadratic form q to the canonical form, then q is said to be the canonical form by orthogonal transformation. We list out the procedure of orthogonal transformation of a quadratic form to the canonical form. First, convert of quadratic form q into x transpose a into x, where x is where a is a real symmetric matrix. Find the eigenvalues of the real symmetric matrix A. Step 3. Find the eigenvectors of corresponding eigenvalues. So where eigenvectors are linearly independent and pairwise orthogonal. So normalize each eigenvector by dividing with its magnitude. Construct the normalized model matrix n and at n transpose. Perform the transformation n transpose A into n is equal to D. Finally find y transpose D into y. So these are Q. So nature of the quadratic form. So when the quadratic form x transpose A into x is reduced to canonical transformation y transpose D into y, it will contain only R terms. If the rank of A is R, the terms of canonical form may be positive, 0 or negative. So first definition is index. The index is denoted by P of the quadratic form. So index is nothing but number of positive terms in the canonical form. Signature. The signature is denoted by S of the quadratic form if is excess of number of positive terms over the number of negative terms in the canonical forms, that is P minus R minus P, that is 2P minus R. Then positive definite. So if R is equal to n and P is equal to n, so if all the eigenvalues of A are positive, then we call as positive definite. So if the quadratic form Q is equal to x transpose A into x in n variables is said to be negative. So if R is equal to n and P equal to 0, or otherwise we will kill eigenvalues are negative. So positive semi-definite. If R is less than n and P equal to R, we will say it's a positive semi-definite. So negative semi-definite, R is less than n and P equal to 0, we will say negative semi-definite. So indefinite means never follow any other condition in the above terms, we call as a indefinite term. Problem number 1. Write down the matrix of the quadratic form. So the given quadratic form is Q is equal to x transpose A into x, where A is nothing but coefficient of x1 square, 1 by 2 into coefficient of x1 2 and so on. Therefore x is equal to this. So now we can, with the given formula, so replace it, we will get a matrix. So reduction of reduce the quadratic form is the given Q is given to the canonical form through the orthogonal transformation and hence show that it is a positive definite. The given quadratic form Q is equal to x transpose A into x, where A matrix is given, x matrix is given, x transpose are given. So therefore from this we can find the characteristic equation. So the eigenvalue is 0, 3, 15. Therefore we want to find the eigenvectors. So the general form is A minus lambda into x is equal to 0. So replace A and I, simplify it, we will get this. Now we want to replace the 3 eigenvalues, we will get a 3 eigenvectors. So for lambda is equal to 0, so we will get a 3 system of equations. So by cross ratio method we will solve first 2 equations. So we will get eigenvector is 1, 2, 2. Similarly we can replace the second eigenvalue lambda is equal to 3. So we can get a 3 system of equation. Choose any 2 non-identical one. So from this we can solve it by using the cross multiplication method. We will get the eigenvectors are x2 is equal to 2, 1 minus 2 for lambda is equal to 3. Similarly we can find the third eigenvector. So by using the lambda is equal to 15. So replace lambda is equal to 15. We will get a 3 system of equations. So from this we can choose any 2 non-similar. So I go to choose the first 2. So from this we will get a third eigenvector 2 minus 2, 1. So for lambda is equal to 15. Therefore hence the eigenvectors are x1, x2, x3 is given. Now we go to find the normalized eigenvector. So x1 transpose x1 normalized eigenvector is 1 by 3 into 1, 2, 2. Similarly x2, x3. So the n is nothing but nodal matrix. So n transpose is nodal transpose of nodal matrix. Now we want to find diagonalization. Diagonalization is nothing but n transpose A into n. So therefore we can replace n transpose value A matrix and n matrix. So multiply it, we will get a D. So now we go to find the canonical transformation. Now we consider the orthogonal transformation x is equal to ny. Then the given quadratic form reduced to, so like this. So x transpose A into x. So x transpose is nothing but n into y. So therefore this we can write in the form of y transpose. So this n transpose is n transpose and y. Therefore n transpose A into n is D. Therefore this is this case. Y transpose is y1, y2, y3. So since it is a row matrix, so y is nothing but column matrix, y1, y2, y3. Therefore, some multiple these three matrix, we will get q is equal to 3y2 square plus 15 y3 square. So now we go to find the nature of the quadratic form. So here rank is 2, index is 2, so signature is 2. So since all the eigenvalues are positive and one eigenvalue is 0, therefore we will give the conclusion the quadratic form is positive semi-definite. So now we will go to see the next problem. So reduce the quadratic form. So q is given x1 square plus 5x2 square plus x3 square plus 2x1 x2 plus 2x2 x3 and 6x1 x3 to the canonical form. So here q is x transpose A into x, the A matrix x matrix x transpose is given. So the characteristic equation is determinant of A minus lambda is equal to 0. So therefore from the characteristic equation we can find the characteristic root. The characteristic root is nothing but eigenvalue. So the eigenvalue lambda is equal to minus 2, 3, 6. Next we go to find the eigenvectors of the corresponding eigenvalue. So the eigenvectors are given by A minus lambda into x is equal to 0. So therefore for lambda we can replace lambda is equal to minus 2 instead of lambda. We will get a first eigenvector. So the first eigenvector is minus 1, 0, 1 for the eigenvalue lambda is equal to minus 2. Similarly for lambda is equal to 3 we can replace it, we can get a 3 system of equations. So from the 3 system of equation we can choose the first two equations. So by cross ratio method, so we will get a second eigenvector minus 1, 1, minus 1 for the value lambda is equal to 3. Similarly for lambda is equal to 6 we can replace lambda is equal to 6, we will get a matrix. From the matrix we can get a 3 system of equations. From the 3 system of equations we can choose any two non-similar. So in that non-similar, by using the cross multiplication method we will get a third eigenvector x3. x3 is nothing but 1, 2, 1 for the value lambda is equal to 6. So now we want to find the nodal matrix by using the above eigenvectors. So n transpose. So n transpose A into n we will get diagonalizable. After that we have to use the q canonical formula. So replace we will get this. So here rank is 3, index p is 2, signature is 1. Since r is equal to n is equal to 3 and p is equal to 2 which is less than n, so therefore the quadratic form is indefinite. Thank you.